Pan. Saturn has 146 known moons. Most of them are round. This one looks like a ravioli. Pan is only 35 kilometers across and orbits inside a gap in Saturn's rings called the Encke Gap. As it moves, it sweeps up ring dust along its equator, building a thick ridge that wraps around its entire middle. The result is a moon that is wide in the center and pinched at the poles, a perfect walnut shape floating inside one of the most beautiful structures in the solar system. Its density is so low it would float in water. It is essentially a loose, frozen pile of ice and rock that Saturn's gravity has slowly decorated with its own rings. Pan is strange, but at least it has a shape we recognize. The next object doesn't follow any rules we know. ʻOumuamua. In 2017, astronomers detected something moving through our solar system that did not belong here. It came from interstellar space, the first confirmed visitor from another star system ever recorded. It was traveling on a hyperbolic trajectory, meaning it had no intention of staying. Whatever it was just passing through. Its brightness shifted by a factor of 10 as it tumbled, suggesting an object roughly 10 times longer than it is wide. A cigar. Or possibly a flat pancake. Nobody agreed. It passed close to the sun and showed no comet tail, no gas jets, nothing. Then, as it left, it inexplicably accelerated faster than gravity alone could explain with no visible source of thrust. Scientists proposed radiation pressure, one Harvard professor proposed something else entirely, and every newspaper on Earth printed that headline. ʻOumuamua is gone now. It left before we could get a closer look. We still do not know what it was. It did not leave a contact number. That came from outside our solar system. What comes next never left. Chariklo. Chariklo is a minor planet about 250 kilometers wide, orbiting quietly between Saturn and Uranus. It is not particularly large. It is not particularly bright. By every measure, it should be completely unremarkable. In 2014, astronomers watched Chariklo pass in front of a distant star. Just before it blocked the light, the starlight dipped twice more, briefly, symmetrically, on both sides. It dipped again on the way out. Chariklo had rings. Not metaphorical rings, two sharp, narrow rings of icy debris, one 7 kilometers wide and one 3 kilometers wide, separated by a 9-kilometer gap. This was the smallest body in the solar system ever found to have a ring system, a feature scientists had only ever seen on giant planets. Apparently, nobody told Chariklo it wasn't big enough for that. The rings likely formed from a past collision that sprayed debris into orbit. From the surface of Chariklo, you would look up and see a 20-kilometer arch of ice cutting across the sky. Przybylski's starfay. Most stars are made of hydrogen, helium, and trace amounts of heavier elements. That is the standard recipe. Przybylski's star did not get the memo. Its spectrum is dominated by rare and radioactive elements, thorium, uranium, and isotopes, so unstable they should have decayed out of existence centuries ago. These are not elements that linger, and in a few days, they should not be there. And yet, every observation confirms them. One theory is that Przybylski's star shares its orbit with a neutron star. The neutron star's radiation may be constantly bombarding the surface, smashing existing atoms apart and fusing new ones in real time, causing a continuous nuclear reaction happening on the surface of a sun. It would mean this star is not just burning hydrogen, it is manufacturing elements, which is either fascinating or deeply alarming, depending on how close you plan to get. That star is doing something we cannot fully explain. The next object did something we cannot fully explain either. The Methuselah star. HD 140283 is a star about 190 light-years away that should not exist. When astronomers first calculated its age, the number they got back was older than the universe. 16 billion years for a universe that is only 13.8 billion years old. For a brief period, this created a genuine crisis in astrophysics. Refined measurements brought the number down to approximately 14.5 billion years. It formed from near-primordial gas in the earliest generations of stars after the Big Bang. The galaxy it was born in no longer exists. It was absorbed by the Milky Way billions of years ago, and HD 140283 has been moving through our galaxy ever since at 800,000 miles per hour. It is currently visible with binoculars. You can look at it tonight. It has been waiting. El Gordo. 7.5 billion light-years away, two massive galaxy clusters are colliding at millions of miles per hour. The result is one of the most energetic events ever recorded. A merger so violent, it generates continuous X-ray shockwaves across millions of light-years. Astronomers named it El Gordo, the Fat One. It contains the mass of several quadrillion suns. Its collision is so powerful that the hot gas from both clusters has been ripped apart and trails behind the merger like twin comet tails. When the James Webb Space Telescope pointed at it, the cluster's gravity bent the light of thousands of background galaxies, turning them into arcs and smears of distorted color. A gravitational lens so powerful it lets us see objects even further away, using El Gordo as a cosmic magnifying glass. We are seeing it as it was when the universe was half its current age. That collision is still happening right now, 7.6 billion years later, in a sky we will never see. The Bernardinelli-Bernstein comet. Every so often, a comet falls inward from the edge of the solar system and passes close enough to the sun to grow a tail. Most of them are a few kilometers across. This one is 140 kilometers wide. Comet Bernardinelli-Bernstein is the largest comet ever directly observed. It has been frozen in the outer reaches of the solar system for billions of years, untouched and unchanged since before Earth existed. It is so dark it absorbs almost all light that hits it. It will reach its closest approach around 2031, pulling into roughly the distance of Saturn's orbit. It will not hit Earth and not even come particularly close. But its sheer size means that as it warms, it will likely outgas on a scale unlike anything seen in recorded history. Think of it as a 140-kilometer chunk of the early solar system slowly waking up. It is not a threat, it is a time capsule, and we are going to get a front row seat. That one is still coming. The last object we're covering has already been here for billions of years, and it just showed us something it had been hiding the whole time. PSRJ. In the constellation Taurus, there is a neutron star spinning 366 times per second. PSRJ exists in a triple star system, a pulsar orbited by one white dwarf every 1.6 days, with a second white dwarf orbiting the entire inner pair every 327 days. This arrangement is so precise and so stable that astronomers were able to use it as a laboratory for testing Einstein's theory of general relativity in extreme gravitational conditions. The results came back accurate to 2 parts in a million. Every pulse from this neutron star is more reliable than an atomic clock. The gravitational dance between all three objects has been playing out without missing a beat for billions of years. It is, in a very literal sense, the universe running its own physics experiment and checking its own work. Our solar system alone contains moons shaped like pasta, comets the size of cities, and stars older than current physics can comfortably explain, which is either inspiring or a good reason to never look up. Subscribe and hit the bell so we can keep finding things that were not supposed to exist. Thanks for watching.